So recently I made a short video about geothermal energy and a lot of you showed interest in this topic. Now, because of the nature of YouTube Shorts, there was a lot that I couldn't fit in those 60 seconds. So that's why I'm going to try to do justice to this topic and dive deeper into it. To put it simply, geothermal energy is the energy in a form of heat that comes from within the earth itself. See, this is something that we don't really think about that much unless you're a scientist or an absolute nerd like myself. But right below Earth crust, there's something almost magical going on. There is a natural process of radioactive decay that happens in rocks in our planet. And what's fascinating about rocks beneath the Earth's crust is that they are in a constant cycle of melting and cooling that produces enormous energy known as heat. See, the temperature of Earth's core is estimated to be around 10,800 degrees Fahrenheit, or it's almost 6,000 degrees Celsius, which is about as hot as the surface of sun. Now, that temperature will progressively drop as we go closer to the crust to about 392 Fahrenheit or 200 degrees Celsius. Now, what makes this energy so interesting is the fact that it's 100% renewable due to this cycle process. So if you're sitting at home and watching this video and presumably you don't know a lot about this topic, you may ask, well, how do we start using this endless pool of hot juice? Well, here's the thing. People have been using this form of energy since the dawn of life on Earth. Some scientific research show that the first organism emerged next to thermal springs on the bottom of the ocean. If we specifically talk about humankind, people have been using thermal springs since the ancient times. Basically, wherever magma pockets get close to the surface, we find a way to take advantage of that. In modern times, and especially in the last few decades, a significant push appeared to use this energy on a massive scale by building geothermal power plants. Now, when we talk about these power plants, there is hardly a better place to go than Iceland. See, Iceland is known for its volcanoes, and that is especially true in the last few years with all the volcano activity there. Because of its location in the middle of the separation zone between North American and Eurasian tectonic plates, Iceland sees a lot of movement that brings magma and heated water up to the surface. Now, Iceland also has cold climate and the need for heating is naturally great, and thermal energy just happens to be there and abundant. Today, 85% of houses on Iceland are heated with the renewable energy and 66% of those are geothermal. Now, Iceland is by no means the only country that uses geothermal energy in this way. Some other examples are New Zealand, Kenya, El Salvador, the United States, and so on. But the question is, if this form of energy is so amazing, why aren't we all jumping on this train and doubling down on it? Well, like with everything else, it's not that simple. Firstly, there's a geographical disadvantage. See, not all countries are near the edges of tectonic plates, therefore the depth at which necessary temperatures can be reached is much deeper. Secondly, there are earthquakes associated with altering the Earth's crust. This is specifically true for enhanced power plants that pump the water into the crust to open up new pockets of energy. Another one is well maintenance. Because of the use of geothermal water, the fluids need to be pumped back into the well faster than they're depleted. Failure to do so will result in depletion of the energy source and render that well useless. And lastly, there is the cost associated with setting up the production of this kind. See, the estimated price for a 1 megawatt capacity is between $2 and $7 million. Now, of course, all of these downsides are not unique for geothermal energy. Matter of fact, every form of energy comes with its array of positive and negative sides. What it does mean is that geothermal energy production will continue to grow and become more and more efficient in areas where it's accessible and economically justifiable. However, there is another form of geothermal energy use that is much more accessible and present in today's world, and those are heat pumps. More specifically, geothermal heat pumps. Now, to explain this in a simple way, think of your car radiator system. See, the pump moves coolant to the engine. There, due to the heat transfer, it warms up while simultaneously cooling down the engine. Then it goes to the radiator where it cools down and goes to repeat the process. Now, geothermal pumps use the stable temperature of the soil to heat or cool the coolant depending on the surface temperature and then bring that into your home. So basically cools you down in the summer, warms you up in the winter. The effectiveness varies due to the outside temperature, but it is up to 50% more effective than air-to-air systems, and it can reach up to 600% efficiency in cold weather, which is insane. Another advantage is the fact that it can be used effectively in any climate. The only difference is that in colder climates, you have to bury the underground coils deeper to achieve the desired temperature. Now, as with everything, there are also downsides with this. One of those will be high upfront costs, which is go up to $30,000 for a single home here in the United States. Another one is soil alteration due to the process of burying coolant coils. And there is also a potential groundwater contamination if the open loop system is used instead of the closed one. So once again, none of these methods are silver bullets. They will all be used wherever it's applicable and financially justifiable. So basically, it's just another way to help us bring down the cost and help us save the environment. Now, this brings us to the end of today's video. There's so much more that you can do a research on this. You can write about this. There are whole essays on these topics, and it's really interesting. I'm sure there are things that I got wrong in this video. I would appreciate if you want to let me know. Just put it down in the comments. I like to be critiqued. That's how I learn. That's how I grow. And thank you for joining me on this. I recently started this channel, so any subscription, any commenting, liking definitely helps. So if you want to do any of those, I definitely appreciate that. I also have a Patreon. For now, there's not really much on it. It will be something for the future, but if somebody feels like they can support, I would also appreciate that. So thank you again, and stay tuned for more.